Hello, my name is Rob Reynolds. Welcome to Mat-073. This is Chapter 8, and we're looking at Section 5, talking about base e for a logarithmic function. So remember, if I just say the log of x, it's understood to be the log of x base 10. And if I say natural log of x, it's understood to have a natural log of base e. So natural log is denoted by ln. And so we're going to be looking at things, logarithmic functions with base e, which happens a lot in finance for compound continuously. We're also going to look at the change of base formula. So if it has some other base other than 10 or e, we can use the change of base formula to get it into a base 10 or e. And then last, we'll end up recapping how to graph exponents and logarithmic functions. So to start out, e is a number, 2.7, 1828, 1827, or 1828, just like pi, which some of you know to several decimal places, 3.141592665. There's more. There's a way to memorize e. It's also an irrational number, such as the square root of 2, which is close to 1.414. Well, e is another number that goes on forever, never terminates, never repeats. I learned it through Andrew Jackson. Loved his wife to marry her twice. He was our 7th president, elected in the year 1828 for 2 terms. 1828. And he was smart enough to solve a 4590, 45 right triangle. So there's the first several digits of e. You'll never need to know that, but it's something interesting. So to find e, or the ln, which is base e, on your calculator, it's underneath your log key on the graphing calculator. It might be located in a different position on your calculator, but you'll just locate the natural log. So for the very first problem, it says, let's find the value of the natural log of 712. Now be careful. Notice the natural log of 712 is not the same value as log base 10. So we want to be using natural log, the ln key. E can be typed in 2 different ways. You can either hit second divide on a graphing calculator and carry it up to negative 1.33, but I think it's faster if you hit second ln. It's the inverse, and that just automatically gives me e carried up. It's a little bit less typing. Oops, I typed in the wrong thing. Let me try that one more time to show you that negative 1.33 is what I wanted. Good. Then negative 2.6. All right, it's not negative, positive. 2.644. So now that we know how to find logarithmic and natural logarithmic functions, what about things that have other bases, such as the log of 5 base 3? How do you type that into the calculator? Because we can only do base 10 if we choose the log key. Remember, that's base 10. Your calculator only does base 10. And it also does base e if you type in a natural log. So we don't know how to handle base 3 yet until we come along with this change of base formula, which says the log of m divided by the log of the base. So for example here, I could rewrite this as the log of 7 divided by the log of 3. And to type that in, I'll make sure I close a parentheses after the 7. If I don't, I'll get a wrong answer. So the danger here is if students type in the log of 7 and just type in divided by the log of 3 without the parentheses, then we get a very different answer. So make sure that you encase or enclose a parentheses after that 7. So this one says the log of 7 divided by the log of 3, we just did that. There you go, 1.77. Good. So next we'll end up this video talking about how to graph exponential and logarithmic functions. In an earlier video, we talked about graphing exponential functions in the form a times b to the x minus c plus d, where b was the base of the exponent, c was a horizontal shift. If it said plus c, I move left, minus c, I would move right. If it said plus d, I would go up, and a minus d, I would move down. And this a is a start value. So I'm going to continue doing the same thing. It's just this time we're going to have a base e instead of a base b. But it's going to follow the same rules because this was a decaying factor if the base was between 0 and 1. Well, that will never happen because if you remember, e is close to 2.71828. Which is always greater than 1. So we don't have to worry about this third scenario being a decaying factor. So for this one, this is really 1 times e to the x minus 0 plus 1 if I were to put it into the standard form. So when it says the start value is 0a, a is not the e, a is the number out in front, so I'd put an open dot there. This says move up 1, so there's a starting point. Remember the asymptote is always at y equals d. So in this case, my asymptote is y equals 1. And I don't have any decaying factors, so I would have some growth here. If you wanted to find additional points on this, you could plot a t-chart. But again, I think that's counterintuitive of what I'd like for you to see. I'd like for you to know all exponential functions go through the point 0, 1, unless there's a phase shift. And the phase shift is, in this case, is a vertical shift up 1 unit. So here's a decaying factor of a negative x, but everything else stays the same. I've got a start value at 0, 1. I'm lifting it 1 unit up. I still have the asymptote at y equals d, y equals 0, but the only difference is this is a decaying factor of a negative x. So instead of growth, I'm going to have decay, which means I'm going to start up high and head down low. You read a line like you read a book from left to right. So from left to right, this is decaying. Another example is a little bit harder. This is a start value of negative 3. This says go 2 units to the right and go 1 unit up. So 2 right and 1 up. Here's a point on the function. The asymptote is still at y equals 1. That's the d shift. And I would be looking for growth or decay. And although I see a negative value here, it's not a negative x, so that's not a decaying factor, but I do have a negative a, so there's one decaying factor. So I would start up high and head down low. Your graph should look something like this. We can, of course, check this answer by going to our calculators and typing in the equation. I'm going to hit second ln for hit the e caret up. Some of you will have to use parentheses here for the x minus 2. My calculator will keep x minus 2 as an exponent, but most of you will have to put that in parentheses. And I'm going to hit zoom 6 to get a standard 10 by 10 by 10 screen. And I'm really interested in this point, which looks like over 2, down 2. So I'm going to check this point to see if it's 2, negative 2. By hitting trace to enter, and sure enough it is. And if I wanted to find additional points to plot more accurately, I would hit second graph, and you can see that the points are pretty difficult to plot, but you can see it's approaching, even out here at negative 5, it's approaching 1, but at least we found one good point. So to continue this, exponents start at 0a. I will move this, let's see, when does 3x minus 6 equals 0? Well, that happens when x is 2, and that's positive, so it's going to go 2 to the right and 4 down. This says go 4 down. And so my asymptote is also at negative 4. 1, 2, 3, 4. So here's a nice asymptote. That's always y equals d. And then I'm looking for decaying factors And although I see some negatives, none of them are decaying factors. I need a negative a or a negative x. And of course, we already decided that the b value would not be between 0 and 1 because e is always greater than 1. So I don't have to worry about that third scenario. So I would have some growth. So I would start low and head high. Now again, I don't know if it's the green function or if it's the red function. You know, to get more accurate, I know it goes through this point, but I'm not exactly sure how fast it's increasing. So this start value is at -5. It's moving, let's see, if I set this equal to 0, again, 3 units to the right, and this says 4 down. The asymptote is also 1, 2, 3, 4 down. And I'm looking for decaying factors, and I think I have 2 of them. I've got a negative x and I have a negative a, and 2 decaying factors cause growth. So I would start low and head high. Now students have a hard time figuring this out, so you might want to practice a couple of these. But of course you could always check these answers on your calculator. But starting low and heading high would look something like this. So checking this on my calculator, I just typed in the function and hit trace. I'm interested to find out if at 3 over, if I was really down 9 units, and it is. So I could also look at rules for logarithmic functions. Well, log functions are the inverse of exponents. So if exponents go through 0, 1, then a log function would go through the inverse, which would be 1, 0. And instead of having a horizontal asymptote at y equals 1, I would have a vertical asymptote at x equals 0. So instead of at y equals d, now I'm looking at this x equals c for the asymptote. And I'm going to look at the general equation here. Y is equal to a, the natural log of x minus c plus d. So I'm looking at this value, this c value, for the asymptote. And in this case, it looks like the asymptote is at y equals 1. And so that actually moved 1 unit to the right. So instead of starting here at 1, 0, like my normal log, I would also move that 1 unit to the right. And then this would be increasing because the same decaying factors for exponents works for logs, and there's no negative a, negative x, or a b value between 0 and 1. So there would be a general log function. Again, if you wanted to find those additional points, you can plot that on your graphing calculators. So this next problem is graphing the natural log of 5 minus x minus 3. So again, the start value, since it is a negative x, I would start at -1, open dot. This is going to be a horizontal shift, so I'll set this equal to 0 and find out that it's being shifted 5 units to the right, and this says 3 units down. So I'll move this 1, 2, 3, 4, 5 right, and 1, 2, 3 down. There's my point. This also is my x equals c for my asymptote. So 5 units to the right is also the asymptote. So instead of at x equals 0, I'd move that to x equals 5. And since I have one decaying factor, which is the negative x, remember e is always a number that's greater than 1, so I don't have to worry about this third scenario. So I have one decaying factor, it's a negative x because, well, the a term is positive. Then I'm going to have decay, and decaying functions start up high and head down low. The next problem has a start value. Well, since I have a negative x, again, I start at open dot at -1. It's not moving to the left or right, but it is going up 1 unit. And the asymptote is at x equals 0. And I would look for growth or decay. And it looks like I've got a negative a term and a negative x. So if you have 2 decaying factors, that would cause growth. And growth functions would start low and head back high. The next scenario says I have a positive x, so I would start at open dot 1, 0. I'm going to move this 2 units to the left, 5 units down. So 2 left, 1, 2, 3, 4, 5 is a good point that I can use. The asymptote also moved 2 units to the left, so instead of at x equals 0, it's at x equals -2. And I got a negative a for a decaying factor, but that's it. So it's decay, which means I'm going to start up high and head down low. And this one's a little tricky. Again, I've got a negative x, so I'd start at -1, 0. I'd set this equal to 0 to find out that this is going to go 2 units to the right because this 2 is positive. So I'm going to go 2 right, and this says 3 units up. So 2 right and 3 up gives me a nice point on my function. This also says 2 right is the asymptote, so instead of x equals 0, I've got x equals 2. And I'm looking for decaying factors, so I can see I've got a negative a term and a negative x. Again, I didn't write the base value, but it's assumed to be e, even if you don't write it down there. I can slip one in if you'd like, but remember the natural log of x naturally has a base e, whether you write it or not. So 2 decaying factors, a negative a and a negative x, cause growth, and growth functions start low and head high. And so the function would look something like this. I hope you found this video helpful. Email me with your questions. Thanks.